Hi, my name is Matt Maxwell. I'm a product manager for Tektronix Real-Time Spectrum Analyzers. And today here I'm going to compare a Keysight FieldFox field analyzer, here the N9918A, against the newest Tektronix spectrum analyzer. This is the RSA507A. This is a battery-powered field spectrum analyzer. It's USB controlled. It's connected now to the Panasonic ToughPad notebook computer, which is running SignalView PC software. So we'll get started here. Both analyzers have been set to a preset condition, and I'm going to first look at the Tektronix analyzer here. No signals are connected to either analyzer at the moment. I just really want to look at the sweep speed. So the reason why sweep speed would be important is to look at low-level signals, or look for low-level signals with a very low resolution bandwidth filter and the preamp turned on, the two ways that you have to reduce the sweep speed. Reduce the noise floor. So set a 30 kilohertz RBW, and then I'm going to set a minus 30 dBm reference level. And then the next thing I'll do is turn on the preamp. Now I'm going to adjust the attenuator to the lowest that is available on the Keysight product is 5 dB attenuation. So I'll change it to 5 dB attenuation here. This could be 0 dB if I wanted to. But for now I'm going to go back to 5 dB. And before I leave this, I probably need to make sure what kind of traces I have, what kind of detectors. So I'm going to use an average RMS detector. I could do some averaging, but it's a pretty stable measurement right now, so I don't think there's a need to average the signal. And then the last thing before I leave this, I need to show the parameters so we can see what the sweep speed is here. So I'll close the settings. So one sweep now is taking about 2.6 seconds to 2.9 seconds. There was one that was longer. It's longer because this is a Windows-based machine, and from time to time Windows does some other things that might impact the sweep speed, but for the most part around 2.6 seconds. So 9 kilohertz to 7.5 gigahertz sweep with a 30 kilohertz RBW. It's fairly quick. It does show the number of FFT points, so that number of points is automatically set to realize the 30 kilohertz RBW. You see, if I change that RBW, if I increase that, the number of sweep points goes down. So let me undo that. There. Oops, I redo. So there, now I've used the undo and redo button to restore it back to the state where it was in, where I'm showing the parameters for the sweep speed as well as the RBW at 30 kilohertz. So very fast sweep, 2.6 seconds. Again, looking for low-level signals here, I see the noise floor is better than minus 110 dBm. The spec on this analyzer would be minus 161 dBm per hertz at 1 gigahertz center frequency. But for practical measurements, I've turned on the preamp, reduced the attenuator, and I'm getting better than minus 110 dBm noise floor, which is very good. So now we'll take a look at the Keysight analyzer. So the Keysight FieldFox, the N9918A, this is a combo spectrum analyzer vector network analyzer, but I'm focusing on the spectrum analyzer. So this happens to be a 26 gigahertz instrument. I'm going to change the stop frequency to be the same as what I have on the Tektronix analyzer. So they're both going to be 7.5 gigahertz to have a fair sweep speed comparison. And then I need to reduce the resolution bandwidth to manual and have that 30 kilohertz. So the sweep noise floor is going down. It's down around minus 80 dB at the moment, but the sweep time is about 30 seconds. So it's quite a bit longer. It's more than 10 times longer than the Tektronix sweep speed, even on the worst case Tektronix sweep speed of 2.9 seconds. I need to turn on the preamp just to make sure that we're giving the best shot here for the Keysight product. So I need to turn the attenuator manual and 5 dB and then I need to turn on the preamp and then change the reference level to minus 30 dBm, just like it is on the other product. So now we're getting minus 100 dB here. There's the line. So there's minus 95 at this band break there. So we're not getting as good noise floor performance here. If we're looking for low-level signals out in the field, this can be significant. You want to have good displayed average noise level spec. That's the number that you look for. And here the DANL is about minus 155 dBm per hertz at a 1 gig center frequency. That's the data sheet for the Keysight product. So it's not as good as the minus 161 on the Tektronix RSA507. When I reduce the reference level, turn on the preamp, and reduce the resolution bandwidth filter, my sweep time here is 30.1 seconds. 401 points now refers to the number of points displayed on the screen. That's another interesting thing. Let me show you one more thing back on the Tektronix analyzer. So with this sweep speed, I also have a limited number of points. That's 801. I'm going to increase that to 64,000. So I'm not quite having enough points to resolve all the RBW bandwidths across that span, but a lot more points with 64,000 points that are available here. And of course, I can export the trace points, save the results as a CSV file, which will give me all the trace points that are available there. So that'll be the results export or the trace. Anyway, that's a quick overview of comparing the sweep times between the Tektronix and the Keysight field analyzers and how that might be important for looking for low-level signals. You need to have a good noise floor, a good sensitivity for the analyzer to be able to see low-level signals of interest out in the field. I thank you for your time.